verify the identity. Now, here, okay, the curl of the cross product between A and B is identical to, now, A divergence of B minus B divergence of A plus B dot nabla. This here is an operator, okay? B dot nabla is different from nabla dot B. See, as I said before, nabla is a pseudo vector, okay? This is an operator. A minus, this is another operator on B. Okay, before you develop this, you see what the order of the tensor. Okay? Now the curl of a vector is a vector. Now A divergence of B is a scalar. This is a scalar joining a vector. Okay, thus this is a vector, this is a vector. So for sure, this will be one free index. Okay, so again, let's start here. This is, let's call U. Okay, and this whole thing, let's call V. Now, this case, U is equal, let's express in terms of epsilon I j k. Now a j b k. This is u I. You see, a free index. That's a vector u. Now the curl of u, let's call this V. Now, as I said before, don't use the same letters that I used there. So let's put epsilon P Q R. Now comes partial derivative. You see, that's U here, U. Now R goes here and Q goes there. Don't forget this, okay? You see, here, delta minus delta, okay, this partial respect to xk of aj bk. See? Now, you see, pj, this will be pj or jp. Now, qk. Now, p is in the second place. You pick k. This will be p, k, and the q will be j. Okay, q in the third place, j in the second one. So then you'll be, in this case, you'll be here qj. Now, here we have over here, if we develop this, we'll have, this will be, let's call this a big delta, okay? Let's do this. So this will be a big delta. Now, partial respect to xq, let's put first aj, okay? Let's do here. I'll put here aj, partial respect to xk of bk plus now bk partial respect to xk of aj. Now delta is this. So let's apply this over here on this term here and this over here on this term here. See, then you have 4 terms. See, 1, 2, 3, 4. You see? Let's call delta aj let's call this term over here a 1. And delta times this as 2. Okay? Now delta times this as 1 is 1, and delta times this term here, let's call 2. Let's develop 1 over here. See? Let's develop the term 1. Okay? Delta times aj partial derivative of bk with respect to xk. Now, I'll write here aj. Let's take the j here. Let's put partial of b respect to xq. Let's take this q out here. Now, let's apply this to that. You see, here I have pj. Okay? Here I have j. So I put ap over here. See? Now, kq. This is kq. So there will be k and k over here. So delta kq, let's say, move k and put q. Now this will be minus, let's put ap like this. ap. Now let's apply this to this one. So I'll write a partial of b respect to x. Now pk, you see, pk, this will be, instead of k here, I'll put p. Now kj, you see, kj, now here I put k, so this is k, this is k. So this is a term which I called 1. Now here we can see what's going on here. See, look. Now this term over here, let's put the blue one. You see, we can see here that this term here is, this case is divergence of b. You see, because this is nabla dot b. Clearly this. You see, look, the free index, you can see in all this term here is p, so this is a vector. So here is a vector a. So this is a divergence of b in this case, okay? Now here you see clearly that k is a dummy index and bp is a vector. This here is a vector. So this is a dot nabla. You see, a dot nabla. I'll show nabla here. Nabla is this term over here. See, look. This is a dot nabla. You see. Now BP, I'll put the blue one over here. You see, BP is a vector b. A vector b. So this is a dot nabla in b. This is a dot nabla. It's over here. See this term over here. So we have then this term here and this term over here. Okay. Let's develop the term 2 now. Okay. Develop this term over here. So it's number 2. It's delta times bk partial derivative of aj respect to x. Okay. Now this is b partial of a respect to x. Now delta pj, you see, pj, this aj, so I put p over here. Now delta k qk, you see, this is qk, or I put k over here and k over there. Now minus, now delta, I'll write down b partial of a partial x. Now let's see. So delta pk, you see, that put p over here, p. Now delta k, this is k over here, okay? Delta kj, you see this j over here, I put k, So we can see clearly here that, you see, that's a dummy. K is a dummy here. This is a vector. Okay? So this will be, this term here will be B, let's put B nabla, A. This is a vector. See, P is a vector. You see this? P is the free index. So this is A over here, you see? Now, you see here that there's a summation, okay, on this vector here. So this will be B dot nabla, okay, on A, okay? B dot nabla on A. That's exactly, here is this. B dot nabla on A. So this is this term over here, okay? B dot nabla on A. Now we want only this. Now is left. So the vector here is B, you see? While P is the free index. And this over here is divergence of A. This is divergence of A. It's quite simple now, okay? Which is exactly like this term over here. This is minus sign, this is minus sign. So let's call this term here, let's put 4 here, okay? And this will be 1, 2, 3, 4. So we proved this identity right here, just using, okay, the permutation symbols and this very, very important identity. Verify the identity. V dot nabla, this is an operator, the transport operator. See, this is a transport. This is a transport. Transport operator. V dot nabla, this operator, this operating on V is the velocity. This is identical to the gradient of this scalar. This is V here is the magnitude of vector V. So V squared over 2 minus V, the cross product between V and rotational of V. Let's prove this identity. So the left hand side, you see this is a scalar operator. You see this whole identity, this is a vector. The vector. So we see one free index. There is only one free index in this whole identity. Now let's show this, or let's write this using Cartesian notation. So let's put this Vj partial respect to xj. So this is V dot nabla. This applied to V, let's call vector Vi. See? This is a vector. Vj partial with respect to xj. This is a vector I. So this is a vector represented by this free index I. So this is identical to, now, V squared, see, you see this is V dot V. This is V squared. Okay, using Cartesian notation, this will be Vj. So this is V squared. So this is a vector, attention, this is a vector. So the gradient, okay, we just use partial respect to xi. This is a pseudo vector. Okay? Now I use here, so this is equal partial respect to xi of Vj over 2. You see? Now I is a vector. You see? The free index, look, the number of free index on the left hand side must be the same number of free index on the right hand side. And if I put I here on the left hand side as a free index, on the right hand side you must put I there, okay? Just to I here and I there. Now minus, now V, rotation of V. Now let's develop this term over here. Let's call this U, okay? And then I will develop right here. Now you see V, the cross product, V cross U. This is epsilon I j k. Now V, you see, V comes first, so this will be Vj and Uk. So this is V cross U. Now I want to get U, okay? So U, the vector U is rotational of V. Attention now. You see, as I said before, let's use different indices. So U, let's put epsilon P Q R. You see, now rotational. Okay, don't forget that. Partial of V partial X. As I said before, R comes here and Q comes there. See? Now I want, you see, UK. I want UK. So here I have my U over here, okay? So UK, I just put, you see, what is the free index over here? It's P. So UK, you see, UK, UB, epsilon, now K instead of P, Q, R, partial VR respect to X, Q. You see, I just changed the notation over here because you see, P here is a free index. Now UK, I have to substitute UK over there. So let's do it. So I'll substitute UK, you see, there. So you see, V cross U, I call W. See, I'll put here. So I repeat there, epsilon I j k, epsilon I j k. Now Vj, now I'll substitute UK by this. So you'll be, I will raise here, okay, and I put epsilon K Q R partial of ER respect to XQ. See, just I substitute UK over there. So this is UK. Now I'll raise here and let's continue. You see, this will be epsilon. I'll write down over here. You see, what is, you see, look here. What is the free index over here? You see, J with J, K with K, you see, a Q with Q, and here R with R. See, R with R. So I, that's why I call WI over here. So WI is equal, now you see epsilon IJK and epsilon KQR. So I can move here and here. So this will be epsilon KIJ. You see, epsilon KIJ, I just move once and twice. Epsilon KQR. You see, now VJ, now partial of VR with respect to XQ. You see? Now let's use here the identity. Look, I need this just to plug here. You see? Now WI is equal, what I said, you see, delta, delta, minus delta, delta. Now, Vj, let's put Vj partial of Vr with respect to xq. You see? Now, here, I and q, you see, the second one with the second one. So I and q. Now, j and r. J and R. Now, this I, okay, will combine with R. The second one with the third one. So, IR, IR. Now, J is the third one, that's Q, J, Q. Let's write down WI. So, let's write WI over here, okay? Now, let's apply this on here. So, here I have V partial of V with respect to X. Now, delta IQ, you see, delta IQ, you see, there will be XQ, this XI. You see, here I have XI, because delta IQ, okay, operate on Q and put I over there. Now, delta JR, you see, I substitute R by J, so this will be here J, and here's J. See, look, delta IQ, move Q and put I, is over here. Now, delta JR, move R and put J, so this is Vj. Now, minus, now, delta IR, IR, you see this R over there, I put, let's write V partial of V respect to X. Now, delta IR, now I move R and put I. Now, delta JK, you see, I move K and put J, so this Vj, now is J over here. You see? It's quite easy. Now, you see, here is exactly this term over there. So let's write down here this term over here. So this will be Vj partial of Vj with respect to xi plus, you see, because it's minus, if there is minus, plus Vj right here, Vj partial of Vi respect to xj. See? Now I complete the right hand side. So let's develop here. See? Okay. I will write here. See, this is minus, see? Vj partial of Gj with respect to xi, minus minus plus Vj partial of, you see, look here, I, this is I also, this is I also, so I is the free index, as we expected. Now, this term over here is a partial derivative of a product, so this will be 1/2 of. Now, Vj partial of Vj with respect to xi plus Vj partial of Vj with respect to xi. So 1/2, this by this is 2, so this will be Vj partial of Vj with respect to xi. So let's substitute this by this over here. You see? Now we have here Vj partial of Vj with respect to xi. Now, this is minus and plus over there. Now we see this. Look this term and look this term. Okay? Now can be cancel here and cancel there. So this term over here is exactly this one. So we proved this relation is very, very important in fluid mechanics.